Right, we're back to the apples with apples analogy, but this time for dividing. So again, the idea with the apples with apples is you want to put things that are alike together when you're dividing. So let's start with the numbers divided by numbers. So 20 divided by 5 in this first example would give us 4. X to the fifth divided by x to the second power. Well, when you're dividing, keep the base and subtract the exponents. And of course, 2 minus 4, y to the second divided by y to the fourth, 2 minus 4, negative y to the negative second. So if I'm allowed to use negative exponents in my answer, I can stop there. Or I can rewrite this as 4x to the third power over y to the second power by thinking about y to the negative second as 1 over y to the second power. For the next problem, we're going to use a similar idea, but first we have to deal with the fact that this entire quantity here is raised to the third power. So we put the 3 to each part, so it will be 2 to the third power, x to the third power, and then the y will be raised to the 3 times 3, because when you have a power raised to another power, you keep the base and multiply the exponents. Same thing with the 4. 4 to the fourth power, x to the fourth power, y to the 2 times 4, which is y to the eighth power. Simplifying here, I get 2 to the third power, which is 2 times 2 is 4, times 2 is 8, x to the third power, y to the ninth, divided by 4 to the fourth power. Wow, that's going to be a pretty big number. 4 times 4 is 16, 16 times 4 is 64, and 64 times 4 is 256. So 256, x to the fourth, y to the eighth. Now we can just simply follow our dividing rules, numbers with numbers, 8 over 256. Well, the thing about 8 and 256 is they're both divisible by 8. And if we divide out, we can cancel, and 8 goes into 8 once, and 8 goes into 256 32 times, which would leave us with 1 over 32, or just if I think about this as a fraction, 32 in the bottom. The x to the third divided by x to the fourth, well, again, we're going to keep the base, subtract the exponents, so it would be x to the negative first power if I write it on the top. Or I could think about this, instead of a negative exponent on the top, I could rewrite this as x to the first in the bottom. Okay, and again, you could look at that by saying, all right, if I canceled out, x to the third cancels with the x to the fourth, except there's one x remaining in the bottom, x to the first. For the y's now, we're looking at y to the ninth minus y, or y to the ninth divided by y to the eighth. Keep the base, subtract the exponents. I end up with y to the first power on the top. So my final answer, y over 32x.